Hi, today I'm going to describe a prokaryotic replication fork. So the first thing I'm going to show you is right here. This is the origin of replication. This is where replication starts along the DNA segment. So there's a few chemicals here I'm going to show you. Gyrase, which is right here and here, is a protein that it relieves supercoiling ahead of the replication fork. By the way, the replication fork is here and here. So helicase, which is shown here and here, this breaks hydrogen bonds to separate the two strands of DNA. Single-stranded binding proteins are represented here, 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 along the length of the DNA segments. So they bind to a single-stranded piece of DNA to protect and stabilize it. So moving on from here, this is a kind of different diagram of a replication fork, but this is showing kind of a more detailed view of it. So the first kind of chemical that comes into play is RNA primase. The RNA primase pieces, which are shown like right here and right here, come in join, and also right here, by the way. They match up with the DNA, and this is where replication begins for each segment of DNA. So the leading strand, which goes on a 3' to 5' strand of DNA, 3' to 5' strand of DNA, is one continuous strand of DNA being replicated off of this piece of DNA. The lagging strand, which goes from 5' to 3', will have multiple RNA polymerases coming in multiple segments of DNA forming behind them. These different segments are called Okazaki fragments. So DNA polymerase 3 is a chemical that comes in and it extends and adds nucleotides to the Okazaki fragments and makes them longer, essentially. DNA polymerase 1 then comes in and removes the RNA primers on the Okazaki fragment in front of it. And lastly, ligase comes in and seals the nick between the Okazaki fragments, making one segment of DNA. And that's it.